Generative AI is not all about entertainment and fun. It's not just for the purpose of creating images, audio, and video from text prompt, and it is certainly not about creating deep graphics or AI dubbing or AI voiceover and stuff like that. They are useful and it is quite fun too, to be honest, but there are various other real world applications where it is actually helping out the humanity. For instance, if you look at this research, which is titled Ultra Fast Deep Learned CNS Tumor Classification During Surgery, in this research, the surgeons have used neural network where the neural network has decided for them that how much healthy tissue to cut out when removing tumors while the patients were on the operating table, and it is huge. So these researchers from Amsterdam University Medical Centers and Princess Maxima Center for Pediatric Oncology in Netherlands built a system to assess how aggressively surgeons should treat tumors. It really worked accurately and quickly enough to enable doctors to adjust their approach in the operating room, which is huge as you can imagine. I will drop the link to this in video's description where you can read more about this abstract. Let me show you the paper too, where they have described it in great detail. Brain surgeons don't know the type of tumors they will remove until an operation is underway. When they have a sample about the size of a kernel of a corn, they can classify it by looking at it under a microscope. Alternatively, they can send it out for DNA sequencing, which can take weeks, requiring a second surgery. However, faster, less precise DNA sequence can be performed on site, and a neural network can classify such preliminary DNA sequence quickly and accurately. This way, a doctor can proceed with the operation with confidence in the tumor's classification. So the way it works, this model, works is that these researchers trained a system of four neural networks to classify brain tumors. Then the authors made a labeled dataset of nearly 17 million artificial DNA sequences of around 90 tumor types, each constructed by assembling random parts from one of 2,800 sequences of tumor and non-tumor DNA. This approach simulated the messy nature of fast DNA sequencing process. And then for each neural network, they randomly selected half the sequences for training and used the other half for testing and validation. And then they trained the network to classify the tumor type. And then at the inference time, all four models classified each DNA sample. So this ensemble of small models into a large model is really working because this system selected the classification from the model that had the highest confidence above a certain threshold, which is amazing. And after all was done, this system returned the results within 90 minutes. So 45 minutes to collect the DNA and 45 minutes to analyze it. And this is huge, right on the operating table. And I'm more than sure that as the time is passing, we are having more and more improvement, not only in the models, but also in the hardware. This time is going to shrink. So I hope that you enjoyed it and you can appreciate that this AI and neural networks and machine learning is really making a difference when it comes to saving human lives. If you like the content, please consider subscribing to the channel. Thank you very much.